let's go over the schedule from here through the entire rest of the semester, since we're getting pretty close to the end. Now, what I've just given you is homework number 11. By the way, we skipped over one of the homework assignments we canceled, and I made that announcement before. So if you look in the grade book, I think it was number 9 that we skipped over. It went straight from 8 to 10, and that's fine. That one's been canceled. So we're meeting here in person live this week. Next week will be recorded, and then our last in-person live class meeting will be on Wednesday, the 1st of May. Then we have our final exam on the 8th. And so in this meeting on Wednesday, May 1st, I'll give you the details about the final exam. Between now and then, I'm going to try and think a little bit about like which computer programs you ought to have installed and ready to use for the exam. And then I'll also be thinking about like what sort of equation sheet or notes requirements and resources you can use for the test. Now, I've already graded your phase 1 of the project, and the rest of the project, the report itself, is due on Wednesday, May 8th, and so that's our last day of the class. So if you have any questions as you're working on that, let me know, but I think that the handout basically gives all the details on what the expectations are for the project. So we just have a couple more weeks left. Any questions about the announcements? No? All right, so we finished quiz 3, the WMS quiz. I'll take a look at what you got through on that. Today we're going to set up a model again out in Morgantown to go through HEC-1 modeling, and it's as sophisticated as we're going to get to in this kind of taste of setting up watershed models online. And we're going to get as far as something that's known as a stochastic model, where we're able to account for the factors of uncertainty. So I know that you've got WMS already going. Let's move to Morgantown. Here's a handout for you that's just roughly going to give you an idea of some of the steps we'll be going through today. But actually, let's just go through it together rather than you trying to do these steps manually and individually. The first thing that we need to do is find the actual location of the site. And so let's go through the wizard and save the project. I'm going to create a new folder where I'm going to call it HEC-1. I'm going to put it in a separate folder. And so this is WMS Day 3 that we're doing now. Day 2 was during last week's recorded lecture. So here's Day 3. We'll save the file, and as soon as you click Save, you see the name that's listed here in the main window and also across the top. And then we need to make sure that our projection is still in Zone 17. Remember that the entirety of West Virginia is within Zone 17, but for the project boundary, it will probably, when you click on Define Project Boundary, take you to the location that you just had for the quiz. Instead, what we want to do is pan over to Morgantown. So you can either type the word Morgantown in the search bar, and I think it will probably take us to the right spot. It did. So we're going to zoom in the downtown area. Oops. All right, I need to zoom in on the downtown area. I think it's a little bit further north here. Yeah. So you can see on the handout I've given you, there's an arrow pointing to this creek. Now, in the homework, you notice that, like, if I just clicked OK right now, it would allow me to download the DEM, and I could place the outlet here on a stream cell, but it wouldn't be zoomed out far enough to get all of the DEM model. And it's sometimes a process that can take a long time to finally have the whole thing, the entire elevation model that you need. Once in a while you'll be able to zoom out and maybe just get a sense for it based on the other surrounding geography. Like here I've got a river on the other side and a highway, so probably that would include it all, but maybe it's too far. So I'm just going to see at this kind of a zoom level, and again, remember, this is the stream that I want to make sure I get the entire watershed for. Let's just see if this is zoomed out far enough that it gets the entire watershed. So I'll click OK, and next, use the web services, next, and I'm going to get all three things at once. I want to get the elevation model, I'm going to get the land use, and I'm also going to have it get the soil type, and I'm going to have it get the Surgo soil type. All right, so National Land Cover Database, Surgo, and then I want to make sure that the worldwide elevation data is also enabled. So you click download, it gives me this zoom level prompt, and that's just offering to like filter the data for an appropriate resolution based on how far zoomed out I am. I'm just going to accept the default suggestion that it has. It'll probably give me another one for the land cover database, 20 meters. That's the default resolution for that data source, so I'll click OK again. And it takes a moment to download the Surgo, especially because that's a pretty large data file. And once it loads it...
How many, you selected the world elevation and which one?
The worldwide elevation data, NLCD 2011, and then scroll down and get Surgo soil data.
Surgo soil, yeah, shit, yeah, okay.
Yep, and then click download data from web. All right, so once it all comes in, we're going to have a lot more soil data than we actually want. It's kind of sloppy in obtaining the data, and so like I want to toggle the two data cells that it did download on and off, because see, this one it got just because it was close, but I can tell that that's not in the area that I'm interested in because it only got the elevation data for the area that I'm interested in. And so this soil data right here, the one that's flashing, I'm going to delete that completely. So if you just right click and let's get rid of it and then save the work.
Is that county based, the soil data?
Pardon me?
Is that county based? Like
Yes,
county?
exactly right. Yep, it's county based.
And another question I had, is there any benefit in downloading them individually and changing the resolutions, you know, per what you want?
You mean downloading?
Like if you would do like the elevation, have a higher resolution, and the soil have a lower resolution.
I see.
I accidentally stumbled upon this, you can do it like that. You know?
Yeah. No. There really isn't any benefit. The lower the number you use, the longer time it's going to take, because the lower number, you know, like instead of 30 meters, if you use 15 meters for your resolution on the elevation,
right,
it's going to be more data. It'll be a finer resolution, and so there may be slightly more accuracy on the watershed area, but it's marginal.
Okay.
I really don't think that it ends up being a meaningful, significant difference. All right, so do you both have basically the same stuff?
What error might have happened?
We have the soil type in a shapefile. We have the elevation data as a DEM, and we also have this land use as a grid. All right, so there's a few things that we need to do. First of all, we're going to create the coverage. So right now we have a let's see, a drainage coverage. So if you right click on, well, I guess let's just go through the wizard and do it that way. We need to calculate topaz. So compute topaz, it'll go through the calculations and put in those streams. Okay. Now, just to make things a bit easier to see, I'm going to turn off the land use for a moment and turn off those. Okay, this is the stream that we're trying to delineate, and you know, the clue of whether or not we've downloaded enough of the DEM is if you look at this stream, look at the blue lines. If one of the blue lines just stopped at the edge, then that would tell us probably we didn't get everything. And actually, I'm still worried about up here. I'm wondering if we got it all. Looks like down here, if you basically draw a line between the blue lines, that's usually the ridge line. So if you look where the cursor is going right now, this, roughly speaking, is going to be the boundary of our watershed.
I think you're good, because I got a little bit more north than you, and it's not anything else.
So I'm going to go next, and I'm going to create an outlet right here. Now I don't want to click on the river itself. Things get a little crazy if you click in the main river. But just on the tributary, I created an outlet, and now I'm going to delineate the watershed. So let's see if it goes all the way up to the top. If we get a flat line at the top, that means I need to zoom out. See that flat line? That means I need to zoom out further.
Oh, yeah, yeah.
Because this isn't a real watershed boundary here. That just means I didn't zoom out far enough.
You may have all the waters, but that doesn't mean you have all the boundaries.
Yeah,
See?
right. And it's not a lot, but we didn't get it all. And I'm not sad that that happened, because I think it's an important illustration that if I start over again, so I'm going to have to throw all this out, just start completely from scratch. And but next time what I'm going to do is project boundary. If I just pan down a little, I'll probably get it all this time. Okay, so it's this stream, and it was up in this reach. Yeah, I can see it now that I know where to look for it. It was this section I was missing. So I think I've got it. Let's try again. We're going to get the elevation, land cover, and soil type. Download it. First it's asking about the elevation, then it's asking about the land cover, like what resolution to get.
Oh, I got a flat line in that direction.
Yeah, in nature it would be pretty uncommon to have a watershed boundary that was perfectly horizontal.
Right.
Like that. All right. So I'm going to close this momentarily and just make sure that I delete the right one of these. Don't need that one, so I'm going to delete it. I'm going to save again now that I've got all the data, and then turn the wizard back on and compute topaz. Okay. And then I'm going to turn off the shape file, turn off the grid. All right.
Well, how come my colors are different? It's just me.
See if you got them.
Probably, do you have this NLCD TIFF turned on?
No.
Okay, so we start the wizard back up, and we're going to create an outlet point right here, and then have it delineate. It's crunching the numbers there. Finally, we have a good delineation with no flat, truncated, horizontal or vertical lines. So that tells me I've got the entire watershed, and it should be about 5,600 acres. Is that what you got, Zach?
Yeah, 5,600, but I have a little bit of a cutoff, so I'm a little lower. You got 5,608.
Okay. Abdulhamid, how about yours? Is it calculating?
Yes, it's not calculating.
Okay. I got 50.
I got 86.
Let's take a look. All right. So what do we have now? We've got the watershed delineated. We've got a land use grid. We've got the soil type. Let's create a new coverage. So right click on coverages and create a new coverage, and it's going to be a soil type coverage. I'll click OK. And what we're going to do is we're going to copy some of the soil type data from a GIS file up into that soil type coverage.
So can we do that again?
Right click on the word coverages.
Yeah, new coverage.
Yeah. And then scroll down to where it says, instead of general, soil type. Did you do this in the... So here, what we're going to do is we're going to select shapes. And I guess before we select the shapes, let's right click on the shape file, and we have to do join NRCS data. And what that join NRCS data does is it puts the hydrologic soil group in, you know, the A, B, C, D, all of that information. That has to be in there. And if there are any blank values, we're going to have it fill it with soil group D. So the default is that that isn't checked, but let's have it check it. And so that if any of these happen to not have a soil group assigned, it will assume that it has soil group D. Okay, so again, that was just here under GIS data, the shape file with the soil, right click, join NRCS data, fill blank values, and OK. And then now what we're going to do is use the select shapes tool and click and select all of the ones that are on top of our watershed. So they're selected. And then we're going to go into mapping, shapes to feature objects. And it's going to go into the soil type coverage. And when you click next, it should show that the SCS soil type is coming from this hydrologic soil group data file. So it's a mixture of B, C, and D. And you click next and finish, then it pastes all of that data. Now our soil type coverage actually has things in it. So if you turn off the GIS file, the shape file, we can still see these colorful shapes because that's in the soil type coverage. Whereas before it was empty, now there's some stuff in that soil type coverage. In previous weeks, I've had you used it's kind of like a key, this IWW curve number. It's a text document that if you open it with a notepad, you can see a combination of land use, soil type, and curve number. We're going to use that again when we calculate the curve number. So right now we've got everything we need for the curve number. Land use tells it whether, so this thing I just turned on, you can see that the yellow colors, these are in urban areas. And all of those colors are assigned a number so that this is going to know, from those colors, we're going to know whether it is a developed area, whether it's water, whether it's woody, and all that sort of thing. Okay, so any questions so far with everything we're up to at this point? Okay. Well, let's just open up the wizard again, and HEC-1 is the model that we're going to do today. Initialize model data. All right, and then you can close it. The last thing we want to do is actually calculate the curve numbers based on the soil type and the land use. And that's under Calculator. So you see that right now we're on the Hydrologic Modeling module. So you got to make sure you're on the hydrologic modeling module, and then the menu across the top includes calculators, and we're going to compute a GIS attribute. So it's going to be the coverage, the soil type coverage is where it gets the soil data, the grid is where it gets the land use, and then we have to import that table. It's that IWW data file thing. Where did I put, oh, it's right now it's defaulting to .txt, and I think I don't have it as a .txt. I think I've got it as .tbl. Oh, where did I put it? It is V, okay, it's on my V drive. Do both of you still have that text file?
Mm-hmm.
Okay. So as soon as those three things are defined, where it gets the soil data, where it gets the land use data, and then the key, if you click OK, then it does the calculation and it gives you the output in a notepad. So for me, it's saying that the weighted curve number for this watershed is 69.5. All on the same page so far. All right, so what we have now is if you click on, let's turn off some of this other visual stuff. Let's turn off the land use. Since we're in the hydrologic modeling module, you'll notice that there's a yellow box at the outlet, a brown box that represents the watershed. And so what it's building is kind of like a schematic model of the watershed. It's saying this it's a watershed that's connected to an outlet through a reach. And so the straight line kind of, from a conceptual basis, represents the stream. And if you double click on the watershed, what it brings up is all the parameters we have to enter to run this HEC-1 model. And in fact, we don't have to do all of them. Let's just take a look. First of all, under basin data, it includes the area of the watershed, and so it's automatically calculated that it's 8.8 square miles for the watershed area. And there's all these strange abbreviations. You see STRQ, like these abbreviations are related to the text file it's building to run the model. And I told you in the olden days what they had to do to run a hydrologic model was they had to start a text file and fill all of this in and counting the number of spaces that they'd calculated, and so all of this information is automatically filled in by WMS rather than us having to format this text file just right. If you click on precipitation, what we're going to do is we're going to assume basin averaged so that there's the same depth of rain everywhere on the storm. And then let's get precipitation data from the web. And so it already knows our latitude and longitude for this location. And let's do it to find out the 10-year storm. So click on 10-year, get data. And so it goes to the NOAA, the National Oceanographic and Atmospheric Administration, and it gets, for a 10-year storm, it's 3.46 inches of rainfall. And then the confidence interval, like the upper 95% confidence interval, is as high as 7.6 inches of rain, and that confidence interval goes as low as 3.2. So it got our rainfall data. Now here for defined series is where we're having to telling it how to distribute that over time. So that's just the depth, but what we want to do is turn that into a type 2 24-hour storm. And so now it tells us over the course of a one-day storm, when is the rainfall actually happening? And we've seen this shape, the shape of a 24-hour storm before. And if you click OK and OK again, now that text file that it's building it's showing the rainfall distribution over a 24-hour time period. You can see the 69.52 is in that text file, so that's our curve number. PB is the precipitation. Do you have a question?
No, I'm trying to see.
Yeah, it's pretty small. Hopefully it's not that small on yours. If you scroll down through the side, the point is that there's just certain flags that it's filling in automatically that we don't have to format that text file ourselves. For loss method, we want to click there and make sure that it has the correct curve number of 69.5 and click OK. The unit hydrograph method now is where we're going to define the lag time or the time of concentration. So we're going to get that based on basin data. So if you click on compute parameters basin data, there's a lot of different options, and you can see here's a list of options for the lag time. And some of these probably sound familiar. SCS method, I know we've done that before, and that's what we're going to choose for this one. So the SCS method, and you'll see that here in the variables window it's automatically identified the watershed length, it's read in the curve number, and based on the elevation data it knows the average watershed slope. So
how come I have almost the same curve number, but we have different slope in percent?
Maybe you're on the other watershed. Remember, do you have two watersheds or just one?
I'm using
the top
right
one?
watershed, yeah.
Yeah? I want to take a look. All right, so based on, so to open that, by the way, to open that up again, since I had you close it, all you have to do is either under HEC-1, do edit parameters under the menu, or you can double click on the symbol for the watershed. So do you see here under HEC-1,
Yeah, I'm there.
edit parameters? All right, you got it open again?
Yeah.
Okay, so the main thing, it has an optional module for entering snowmelt data, but the main things that we want to double check is the area of the watershed, the precipitation, and the loss method, make sure the curve number is in there. The unit hydrograph method, make sure that a lag time is calculated. Your lag time, do I remember, was it about 2.0 hours because your slope was a little bit less?
At that time?
Yeah. My T-lag is
2.03.
2.03. So because if you remember the formula uses the slope, so since it thinks your slope is a little bit less steep, 13% versus my 15%, that's why your lag time is a little bit longer.
Okay.
It's okay. All right. So what we can do now is here under the HEC-1 model, if you have it do run simulation, this is one of the tricky things that we sometimes get an error message from. HEC-1 is kind of an old model, and it can't handle it if your model file is like deep buried in so many subfolders. And so it's a good idea to try and save the HEC-1 file pretty close to the root of the C drive. So what I'm saying is if it's a folder within a folder within a folder on your desktop, you might get an error message. Not always, but oftentimes there's error messages. And so I'm going to call this Morgantown, and if you look, it's on C temp 670 demo, but that's only like 2 folders deep when I was creating the location.
What you store it on the desktop?
I think not on the desktop, but on the C drive. If you create a temporary folder within the C drive, I think that's the best solution. Because the desktop is several subfolders deep inside of the C drive. And sometimes the HEC-1 model can't operate with lots of different subfolders. What it does is it runs the HEC-1 model. Did you both get it to say normal end?
Yes.
Zach?
I deleted my one watershed and it took me back, so I was watching.
Oh, okay. Once it finishes the calculations, then it creates a hydrograph, and If you double click on the hydrograph, then you can see what's the peak flow rate. You can see when the flow rate occurs. So it's saying that our peak flow would be 1073 CFS, and it happens 840 minutes after the day begins, because 0 is the beginning of the day for that 24-hour storm.
So wait. Can you go back to your graph?
Mm-hmm.
And your peak flow was 1073?
For mine, yours will be a little bit different though, because your lag time.
Okay, but I had the same time of peak.
That's fine. Yeah. Is the peak amount different? Is it saying maybe slightly lower, but still around 1,000 for you?
1042.
That's good. Yeah, 1,042. The difference there, that's just a couple of percent. Like, you know, the difference, we're talking 2-3% is all. So our models are actually both pretty similar, in spite of the fact that your slope was 13%. So what's nice about this, let's go to Hydrograph Delete Previous, and it makes that one go away. We can change things. Like if we wanted to say, well, what then happens? That was for a curve number of 69. What if the curve number was actually 65? So click OK and done. HEC-1, run simulation. So it'll tell you what does the watershed look like if the curve number is lower. So remember, when it was 69.5, my peak was over 1,000. And now it's telling me the curve number going down to 65, the peak is only 763. So sometimes you have to do what's called a sensitivity analysis. And have you heard of a sensitivity analysis where what you're doing is you're varying one input parameter and you're seeing how does the model react to changes in that input parameter? One of the nice things about this program is it allows you to do like lots of calculations over and over again to test out what is the sensitivity of a variable. And so let's delete the previous hydrograph. And here under HEC-1, there's this option Stochastic Modeling. Stochastic just means kind of like with a variation in statistics, or if you're looking at a range of possibilities, kind of like the probabilistic range of possibilities. Before we start the stochastic modeling, I just want to, but let's say hypothetically, what if we're not exactly sure what the curve number is going to be? If we want to know like what's the spectrum of possibilities, then we can define a stochastic model, and what we're going to do is add a variable. So if you've got this define stochastic model checked, then add a variable, and what we're going to do is it's going to put in a different curve number. It's going to use a range of different curve numbers, and so right now it is doing like 100 different runs. That's probably more than we want. Let's have it do like 20 runs. Okay. Yeah, 20 runs. And what it did was it's saying the default is that the minimum value would be 60, the maximum value would be 90, and the starting value, like kind of the midpoint, is 75. So this normal distribution, it randomly picks what to assign as the curve number for each of these runs. So that's probably a little bit wider than we'd want it to be, and the values aren't quite right either. If we know from what our calculations was, it was 69.5, let's have the start value be 69.5, and the lowest we'd expect, maybe it's as low as 64, and maybe it's as high as 74. All right, so now all of these values are normally distributed.
What do we say our maximum value was 74?
Yes. So it's kind of clustered around 70, but it could go as low as 64 and as high as 74. So if you look, what it's going to do is it's going to calculate this model, 20 different runs. It's going to do different curve numbers. And this key of -1, now it's been a while since I did this, but I think what we have to do is we have to go back into our model and we have to put in -1 for the curve number to tell it to use these values instead of its own values. And so open back up the model, and here under loss method for curve number we have to replace -1, and that's how it knows to look someplace else for the curve number to use for each run. So over here in HEC-1 stochastic modeling, when it comes to the -1, that tells a separate module to kick in, and that we're going to do 20 different runs with a variety of curve numbers. And so it's going to run this whole model 20 different times, and then the hydrographs that it gives us will be kind of like an envelope of possibilities.
Where was the -1 we inputted?
You open back up the HEC-1 parameters again, so you can get to it through either HEC-1, edit parameters, or if you just use the hydrologic modeling module and then the select basin and double click on the basin
For some reason mine's not
under the loss method.
selectable again.
It is double click on the.
Do you have the select basin tool over here?
Oh, there, okay, good, got it.
All right, so you need to make sure that for the loss method you have the curve number set to -1. All right, so this is the big payoff. This is the big moment here. When we go back up to the HEC-1 model. The stochastic modeling is all set up. Now all we have to do is have it run the stochastic model. So click Run Stochastic Model.
To 100?
Mine was only going 20.
What goes 100?
Okay, that's fine. It'll just take a little bit longer. When I click OK, error, huh?
Okay.
Yours worked?
Yeah, mine's working.
Mine worked.
Yeah. Maybe I need to save my simulation again, I think.
Yeah, mine's running. Is yours running?
Yeah, I can see yours running, but mine's not running. Mine's just
Finished. Yours
Finished.
ran, but just ran one time, I think.
it just is finished.
Oh, because you didn't add variable, okay. So we'll leave 20. I'm gonna figure out 20. Then do this.
Did
Define.
mine.
Then you guys press add variable. Okay. And then, I couldn't get mine, let's see if yours is. See, when you go this way, you can't, nothing shows up. You have to do the double click on basin. Yeah, you're good, that's good. Okay,
I think mine is working now.
yeah, okay, just hit that.
The issue was just what I'd said before, is it doesn't like going into subfolders. So as soon as I told it,
No,
No, that's the same thing, he got up subfolders.
I'm back to error.
So save it real fast for losing. I think you should move your folder.
mine's on 17. When it finishes and I'm able to pull up my hydrographs, I'll show you. All right, yeah, mine worked. Let me see if I can get yours to work.
Did you just press close to get the open hydrographs? Resolution.
The sensitivity analysis tells you the worst case scenario and the best case scenario, and this is maybe a little bit hard to see. So if you right click on the hydrograph, you can export the data. So you can export/print, and if we want to get the actual text data, so you'd switch that top one to text/data. We'd want it to be a file, and you can browse to the location where it's going to save the file.
The export or print.
Yeah, I don't want to print.
Should we make it J?
Text/data, file,
Okay, file, browse.
browse, and then call it like stochastic.txt. No, actually .csv, because then that will automatically tell Microsoft Excel to open it. Okay. Export, and then the one last thing to change is, see the export style, change it, instead of list, change it to table.
Where?
This one, instead of list, do table, and then do points/subsets.
Table.
Points/subsets, yep. Export. Alright, so now if we go find that, the one that it just created, I called it stochastic. Where did it go? Maybe it's... Oh, many. There it is, stochastic. So if I open it, then it's going to have all those runoff hydrographs, column by column.
So doesn't matter where you save it, where you export it to?
As long as you find it. And temporary, I think, save and see, I think it disappeared. After a while.
I'm going to try again on one thing. I know we want it to be a table. Oh, comma delimited. Table. Let's use it subset points. Yeah, that's not. One last thing. I'm going to try it again. Export text data file. This time I'm just going to do .txt. So stochastic3.txt. Table.
Points, subsets.
File, open. Many. Alright, we want it to be able to see all files, and it is going to open up this text file, and it'll give me the import wizard, and then I can tell it to use commas. Do you see what the problem is? It's treating each storm as a row rather than as a column. So rather than get wrapped up on exporting the data, I want to show you one other thing before we finish up. We've just got a few minutes. And so this was the range of curve numbers. You can do the same thing for precipitation. So if we go back to stochastic modeling and add variable, the other thing you can do besides curve number, there's only two things. The curve number, you can do a range of curve numbers, and you can also do a range of precipitation. So if you remember our, I'm going to delete the curve number now. I'm going to delete that variable. Precipitation, I think, what did we have, like 3.8 inches? Well, we could have maybe as low as 3.6 is in the middle. The minimum is 3. The high maybe is 4.2. 3.6 was the beginning point. So the idea is that we can have the, okay, standard deviation maybe, that's talking about the how wide the bell curve is for a normal distribution. Maybe the standard deviation is 0.5. So then it has all of these values in between the allowable range. Now what we would have to do though is now we have to go back to the model and put the curve number back in, 69.5, because we used the -1 value previously. And this time for precipitation, instead of average precipitation 3.46 inches, we need to put the -1 into the precipitation amount now. So it's kind of like you're telling the model where to override the single fixed value with the stochastic amount. So here, just double check for stochastic modeling. What we're going to have it do is override the precipitation data with all of these various possibilities of what the precipitation could be. Now it doesn't have to be like this random distribution. If you wanted, you could do it in order. You could have, let's say, let's just do 10 runs.
So when we go back to the parameters, what do we change?
You got the rainfall.
Put the curve number back to 69.5.
69.5.
And then for the precipitation, change that to -1.
-1, okay.
Okay, this time rather than having it being random for the precipitations, let's manually type it in. 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, and so on.
For the runs.
Yeah. So now each run, instead of being random, is kind of like we just want to find out what's going to be the effect of our own distribution of rainfall. And then we can run the stochastic model. Oh wait, first delete the previous hydrograph because otherwise they're going to be on top of each other. So hydrographs, delete all. And then we can run the stochastic model. It'll go through the 10 runs. All right, finished. And if I open up the hydrograph, open up the hydrograph, then run 1 is this first one with the lowest amount of precipitation, and it gradually is increasing. That still kind of drives me crazy because I've been able to export that data in the past where it made perfect sense. It's been a while since I did it. So this is rainfall stochastic.txt. I think what I want is a table with points/subsets. So open rainfall stochastic with commas. Yes, I think this is finally going to make sense. All right, now we have it. The first column is time, the second column is runoff, and so this is run 1. We can see all the different runs. Yeah. So the key again when you're exporting the data is text/data, file, browse, pick some name. .txt. And then we want it to be table points/subsets.
How come mine is different colors?
I don't know. So then we had 10 runs, and so we'll have, you know, here's the first run, here's the second run, here's the third run, the fourth, and so on. So if we wanted to, you know, the time column, all these are the same. We could delete all but just the leftmost time column, and then this would represent run 1, run 2, run 3, and so we could recreate this same figure with whatever colors we prefer and chopping off the time that doesn't matter and that sort of thing. So that's how you can do a batch simulation with WMS. Any questions about that?
You said when we import with the wizard, it's columns, right? The wizard.
Yeah, that's right, comma delimitation.
Okay, let's see.
All right, that's the last thing I wanted to show you with WMS is number one, how to do a HEC-1 model, and number two, if you need to run a lot of HEC-1 models, it's a lot easier to do it as a batch rather than manually. Just to reiterate where we're at in the semester, things are drawing to an end. So next week we don't have a class meeting. That's going to be recorded. And then our last live class meeting will be 2 weeks from tonight. We're going to talk about underground hydrology and aquifers that night. Then our final exam and the project is due on the May 8th. So please check on MU Online to see if there's any discrepancies in the assignments you've submitted versus what's graded. Double check the, oh, I've got both of your exams up in my office. I keep forgetting to bring them down. Are you interested to have your graded exam? We can go up and grab it right now. Just double check the grade book to see if there's anything I need to adjust. Please let me know. And
For the final, like I said, it'll be cumulative, but will be mostly after the first test, or?
there will be an emphasis on the materials since the first midterm. Yeah, so proportionally more of the points will be the recent stuff since the first test.
Gotcha.
Yeah. All right, that's it for tonight.